Krishan, this is Rikhil, we're from Arkera, and we're going to talk to you about, it's more like our road to a smooth breakup. And obviously there's a kind of, because not everything is as smooth as you hope. So just quickly, what is Arkera? Because I'm sure everyone knows who Nutmeg is, but we're a little bit smaller. So we're helping financial institutions make sense of the world's news. But not like most fintechs, we work with news data, text data, rather than numerical data. So our scaling problems are a little bit weirder because there's a lot, numerical data is a bit easier to calculate. Text data is like you can have an article that's crazy long or crazy short, and we still have to scale with that. We do a lot of processing, and we have three main teams. And so the talk we're doing is purely from the engineering point of view. But we'll try and bring the other points of view as much as we can, which are like the data science team and the domain team. We do a lot of like the business, looking at it from the business and the financial point of view. Cool, and just to introduce ourselves quickly, so I'm Krishan, I'm CTO. I was first hire at Arkera, started like 2 weeks after it started, and it's been 4 years now. And this is Rikhil. He joined us about a year and a bit after we started, and he was our first engineer. So until then, we just had data scientists and me supporting them, and a whole bunch of domain people working on it. And so that brings us to like how we got to the problem of monolith in the first place. Someone asked me at work the other day, which is like the question of, if you started now, would you start with microservices? And I think my answer would still be no. We would still start with a monolith and then break it apart someday, which I can't rationalize that to myself. But it's what I would answer. So where do we start? We had one big monolith. We have 3 data scientists writing code into there. So you can imagine the challenges that brings along. And we had me trying to like coordinate and add CI and Docker and stuff that really I wanted to make work. This grew very, very big, very, very quickly. You can imagine there's 4 guys working on three guys and 1 girl, working on a single place, and the business problems were kind of very exploratory. We didn't really have business models set down. Like we kind of knew the area we were working in, but not really what we were working on. So like it literally just exploded. We had lots and lots of features, lots of APIs, lots of interesting, cool data science stuff that nobody knows how it's going to scale. And it was serving an app on the front-end side, so it's something that clients or wealth managers would use. And obviously, there's a big database, and the majority of our content comes from the web, as probably most people does. So lots of scraping and looking at public sources of information. The nice thing is we did use Docker from day one, so there's a lot of parts of the conversation which are made harder if you're not using Docker. But it's like a tone through our thing that Docker made our life very, very easy. And then yes, we kind of already had a conceptual split between the monolith having an API side and a worker side, which will come to it as well. But essentially, we had one big common server. And yeah, it was fine. So we had 3 data scientists and me working on this, and everything was happy. The APIs were working for our test app. Like there was maybe 20 people using the test app, us and our investors. Everything would work until we started looking back at it. It was about when Rikhil joined that we started looking back and said like, so we had the worker that had countless responsibilities. I didn't honestly, and honestly I don't remember most of them. But you can imagine the biggest problem is like when you have a new feature to add, it would undoubtedly go into one of these. And so we knew we needed to split up. We kind of knew why we need to split up, because 20 people were using it and we could already feel the like seams bursting a little bit. Like, why is this happening? It doesn't even make sense. We did that very small server. So cool. Rikhil's going to take us over the challenges.
Just before I jump over to the challenges, once again, overall consensus of the young crowd that listens to me today. So like, if I can just get a show of hands of people that have worked with a microservice architecture and the monolith. Okay, kind of what I was expecting. In that case, most of you will be able to empathize with the challenges that we faced. Firstly, to speak about development time. So, as Krishan said, at the time there was only 1 engineer, and we wanted to scale up the engineering team. It was unfeasible to have just 1 engineer working on the product. So, having everyone contribute to 1 repository was just extremely unfeasible. You can imagine the merge conflicts if you had 3 people contributing to 1 code base. And then all of the code was going into a single repo. So the practices were like forcibly bad. For example, if you have a data model and you want to update the data model, but the data model is referenced in like 400 other lines of code, and in 1 pull request, you'll have to update the data model, but also update those other 400 lines of code in the same pull request. And as engineering practices go, like for reviewers, for the code writers, this is not feasible in the long term. We also had a mix of data science and production level code, and you can imagine the bugs that were introduced from the various code writers, fixing these bugs by people that not only one person had contributed the code to was difficult. We had like crazy levels of dependencies between our codes, and all of these dependencies are like super blurry, super murky. It was hard to like untangle the code base. Overall, things were working; they were good, but we knew that there was a lot of improvements to be made. With regards to monitoring, so having everything in a single repo was easy, but having like logs was really difficult. So monitoring where calls were being made, the flow of calls, function calls, etc., was super difficult. Having everything in one repo, and you can imagine like having our logs in one place, like filtering through these logs, like going from one log to another log in the logical flow of API requests was super difficult having everything in one repo. I'm sure some of you can relate to some of these challenges. In terms of stability, like if you have one API which requires 2 minutes of computation, and some APIs you take 2 minutes to run. So you can imagine like some APIs take 2 minutes to compute, like, and this was definitely like one of the blockages with having a single repo. And it was just something that we had to accept. Like we knew that this was a problem in our code base. And if you can imagine, if we had one repo and one API, then any bug that would occur or any expensive resource would lead to, since this was the only selling thing to the app, would lead to the app going down. And clearly, it's not feasible for the long term. Here, the goal was scalability. So obviously, scalability was super difficult having a monolith. So let's talk to the example here. We have one API which is super expensive and a second API which is super cheap. And as the number of features and number of users of our application increase, we need to scale the API for our events, naturally. But scaling this and having everything in a single monolith would require scaling the entire system. Everything was packed into one. And clearly that's super expensive. So these were some of the challenges that we faced. Other challenges we faced, very high level, was it was really difficult to accommodate new feature requirements. Again, iterating through POCs and shutting down existing features was super difficult. Again, this refers back to the murky injection of dependencies that we had in our monolith. We wanted to allocate ownership of our code base across different team members. And again, due to our murky dependencies, this was super difficult. Like breaking it down into logical components into a large monolith was super difficult. Decoupling technical decisions from the overall objective, and isolating different functionalities within the monolith. Identifying the dependencies, like everything was in one repo, everything was a mess, the dependencies were unclear, the logical components of the code were super unclear, and breaking it down, like monitoring, logging all of this information was super difficult.
Cool. So how do we get started? So most of you said that you are working with monolith now, so it sounds obvious, but like the first thing if you want to go towards microservices, stop making your problem bigger. It is challenging, obviously, with business requirements and new features coming in all the time. Like, how do you justify microservices? Like a cool new word, but what does it actually mean? And for us, it was like we made an argument, not this one, but we had it like written down. Like, this is what it will cost us to do it, and this is what it will and how it will benefit the company. And because of the nature of where we were as a business, we were still iterating a lot. We were still trying to find our what exactly we were doing. We knew what data we were getting in, and we knew what we were showing the user, but how we do it was still unclear. And so it was a very easy sell to the business when we put it like that. And so we started, I think it was about a month after Rikhil joined, or maybe just a week after. We'd already decided we're working with microservices. New feature request came in, and it was like, great, this is clean, this is a nice isolatable part, let's do it somewhere else. One of the things that we did very, very early on, and I think it definitely led the way or cleared the path for doing this long term and like having this as a thing that we do forever, is laying down some principles. And like just like kind of knowing what you want and what you don't want, and like having a good business case for why you're doing it made that very easy. So yeah, I mean like sticking to them and iterating them is super important. But a couple of the ones that we used, and we have this written down somewhere, I wrote them from scratch, is don't try until you know how to. So for example, like setting up a new service was very tempting, and then like once you got to the next one, it's like, oh, can we abstract the parts of the first one and reuse it? No, stop. Like because we've done one, we have no idea what the third one's going to look like. We have no idea what the 100th one's going to look like, and we want to be at 100. So don't abstract until it's painful enough that you want to abstract. And like this rule got us to a really good place in terms of having core libraries, having like deployment patterns that just scale really well. Like we know what parts work, we know what parts are tedious, and parts that aren't tedious, they'll still be repeated, but nobody cares. Like, they're just there. Data is more valuable than best guess. So again, it's kind of the same thing, but don't like, oh, I want to make this more abstract, or I want to like let's plan this for a week and then we'll do it. But actually, planning for a week gets you nothing, because if you do it, like do the second service, do the third service, you'll figure out like what the problems are along the way. Build it into your time estimates. Like, don't just assume everything's going to go well, but like try and do it and gather feedback as much as possible. This is a super blurry one and it's super difficult to actually do, but it is like, for us, it's super important, because if you give people the opportunity to do the wrong thing, they will do it. Not out of wanting to do it, but people have time limitations. People have other shit they want to get to. So like it is difficult to concretize this, but it is a big principle for us. Acknowledging shortcuts. I think it sounds obvious, but like we have a rule whenever you take a shortcut, you mark it as a to-do and a heuristic into that. And like when we were doing a lot of the services, like we do the second one, we do the third one, you can see now, oh, I took a shortcut here, put it in the backlog, and that will help everyone in the future. And this is like, again, a super blurry one, but actually very, very important for us. Recognize where innovation is needed and where it's not. So you're doing your second service, you're doing a third service, you're doing a fourth service. Like, should you start messing around with the deployment? Probably not, because you're making these services for a good reason. You're making these services to serve a user something valuable that they want. Don't fuck around with deployment. Like, make a task. Someone will get to it in the future when we have time for it. Finding solutions. So we had already broken our Carbon server into API and worker, so we kind of knew like how we want to work and how we want to be doing things. And in the meantime, we had created a separate service called Picasso. We didn't think of it as a service. We didn't think of it as a microservice or any of the cool words that we use now. We just thought of it as like, oh, someone needs to solve this problem. Like, just go away and solve it. And someone solved it in isolation of our monolith. But looking back, like it laid down a lot of the groundwork that we then used to make our other services good. Although at the time we didn't know a lot. And like this is a really big point for us, which is microservices was not the goal. Like the goal was not let's make lots and lots of small services. The goal was to solve the problems that we had. And so at different points, it was like the problem. Like I'm not really a big fan of the word microservices. Like it's the word micro in it. Like it implies size. But for us, like the size of the services was not the key. The key was make development faster, make it more scalable, make it more monitorable, make it easy for someone to have. Here's a bug, here's the problem, fixed. Right? Like not a week of nonsense going through teams and juggling different dependencies. So on the thing about not drying before you know how to. So journalist was our first service. That was the one that Rikhil helped us write in his first week. And this is kind of the process we went to. Like it's very basic. Like you literally just from scratch, you have to make a service, go do it. And it was like roughly 5 steps, but a lot of effort. I think it took like a month to do the first one. But the business logic was very small. It's because along the way we started to like question ourselves, like should we do this, should we do that? We didn't follow the same principle. And our 150th service, which was like a couple of weeks ago, Vulcan, actually his name is not Vulcan, I just picked a cool one. I don't remember what it was. Our 150th service, like a couple of weeks ago, and it's super easy. Now we have a skeleton, you just clone it down, you write your business logic in one place, you have an API that you have to write and a client that someone's auto-generating, which is awesome. and then you start using it like with a client library. You don't have to like mess around with HTTP APIs in your like use of it. Like it just works. Like that. Once we had an engineer that commented like, given everything that's moving at the same time, it's a surprise everything works. But it's not. When you think about what it actually is, it's not surprising. It's just simple pieces everywhere. They link together really well. So in summary, what we're going to do now is go over some of the decisions that we made along the way, some of the challenges we had, and how we chose the right solution. Not right, how we chose the solution. Explicitly, there is no right solution. But it's important to remember that these are the things we ended up with or chose at the start, depending on which one it is. It's not about like getting the right answer at any time. It was about knowing what the problem was and then solving it. And then the main problem we're going to talk to you is about how to size services. Like, what is a good size for a service? Like, why should this be a service, and or should it be attached to an old service?
So some of the decisions along the way, one of the key decisions that we had to make was choosing our orchestrator. Right at the beginning, we had Elastic Beanstalk, but when we knew like we wanted to break up the monolith, it was clear that Elastic Beanstalk wouldn't solve the problems that we were out to solve. The real orchestrator which we moved to was ECS. And even more recently, we moved to Kubernetes. And now we're working on this project. We're spending a lot of time decoupling ourselves from AWS. And the reason for this is for future requirements, potential requirements of client-side deployments, for example, but also the other benefits of like cost saving, which come along with AWS which come along with Kubernetes. And as Krish mentioned, it's like Docker and Kubernetes, but at the same time, it's like the service's responsibility is just to orchestrate a bit of business logic. It's not to deal with deployment mechanisms, and that's where like our orchestrator and our CI/CD pipeline were key. So here, as Chris said, like if you give someone room to fiddle around, then they will. And we solved that with our CI. And therefore, when someone is writing a new service, they wouldn't have to deal with any of the deployment. Like every deployment for every service looks the same. For service discovery, all instances of a service, they register themselves in order for clients to easily access them, and they should also deregister themselves. This is clearly not a problem related to the business, so we wanted something to do the heavy lifting for us. So we turned to our orchestrator, and ECS provides an easy way to set up DNS-based discovery, and it was a clear choice for us because we're already used to thinking about HTTP APIs. And a little bit more on service discovery is like now that we moved to Kubernetes, we rely on within the cluster intra-cluster communication, which we use for our services, and that also contributes to cost saving. Krish also mentioned a little bit about Carbon Server. So Carbon Server serves two functionalities. It had an API and it had a worker. And as we continue to break down our monolith into microservices, we clearly discovered that there was a break between the functionality, the responsibility of the different microservices. So there are one set of microservices which was simply just an API and they just had REST endpoints, and the second type of microservices which had workers, and these would be serving asynchronous processes where they just read something from the queue, do some processes, and communicate with other services in the architecture. Another thing we did in order to define our service structure was write an API design. So this is a screenshot of our documentation, our wiki, and it focuses on that API design. And what this serves is, like, why does API design matter? Well, API design matters because if we have a clearly defined API design, which we've just spent some time on defining properly once, then we don't have to worry about API design in the future moving forward. Like every service conforms to this API design, and conformity I'm sure we'll come to in a bit, was like super key in other decisions that we had to make in the process of breaking up a monolith. As we started breaking up our monolith into several microservices, we got to the second or third microservice, we got to like journalist, Picasso. We found the same base classes being defined in all of these services. So we immediately decided to abstract away our base classes or our key components into a library that we called Carbon Core. And over time, as we defined more microservices, as we had more abstract classes, more base classes, we started moving all these logical components to Carbon Core. And effectively, what it looks like is that we have one library, Carbon Core, and we have 100 or 150 microservices, however many, all importing base classes and abstractions from this library. And what it means is that we don't have repeated code in all of our microservices. It just makes them lighter. So as soon as we find something to move over, we'll move over. And it's nice and easy because that core library is strictly versioned. And versioning is super important. We don't have any breaking changes. Like services can be updated independently and whenever someone feels like doing so. Again, going back to the other point that both Krishan and I have mentioned is like there's no point of innovating on a service like one by one. Just innovate once, put it in the core library, and then we can use the same innovation, the same thoughts, the same decisions that we made at some point in all of our microservices. So when defining Carbon Core, like one of the questions we had to ask ourselves was, or when putting something into Python Core or Carbon Core, one of the questions we asked was whether we should put this component into Carbon Core as a server, as a library, or we should just make a service for it. And initially, like a couple of years ago, we were more tempted to put all of our base classes into libraries. So we would immediately just, our default behavior was just to make a Python library for this feature. And an example is like we have a wrapper around requests. So we use that wrapper to communicate with other services, external or internal, and we just slap this into Python Core. But going back to the question of whether like we put a feature into a service or library, was that it's always better to write a service than a library. And the key is because every service has an API, and if you just define a client for that service in any language, then you can reuse the same components, the same logic that you've implemented once in any language. So for example, like most of our services right now are Python, but in order to move to a new language tomorrow would be close to zero effort because we just have to define a client in that language, and we can use that client from services written in different languages.
Cool. All right. So as promised, we'll get to sizing services. So why is sizing important? So it definitely wasn't a question we asked at the start. I mean, we didn't think about like what should be a service and what shouldn't. And like even from the start, like we knew micro was not the right thing for us. It's not about having lots and lots of small stuff. It's about having lots of correctly sized stuff. But what is correct? So the first thing we had to define for ourselves is what is a service, or what does a service mean for us, really, like for our business. And these were the three things that we thought were most important. Right, with the first one being the most important out of the most important. It has to be independent, deployed, scalable, monitorable, and iteratable. So obviously we said we started with these three, but even though we could call these three services, like they felt wrong, they were just not right. Like they didn't abide by these rules. They were obviously not correct. And so we came to the conclusion that our only problem was sizing. Like these are services. Like yes, they're fine as services, but they're too big. Like they do too much. And we tried to quantify what could people do. And so we came up with lots of definitions, right? So like single, meaningful, achievable responsibility. Like a service has a single, meaningful, achievable responsibility. But again, it's still fluffy. And like we started defining like different types of service. So adding to our principles about like what is your service trying to do, and like which of these n types does it fit under, or do you have to create a new one? And these are the three main ones we have at the moment: so resource management, coordination, and calculation. calculation. Nothing really interesting. I'm sure there was something similar for everyone. But we came into a new problem. So there's a lot of people believe that services should not talk to each other, but we did not take that assumption at all. We were happy for services to talk to each other as long as they scaled correctly when they did so. But one of the problems we came up with then was deadlock. So one service or the service is not actually as important as the container. One container calls another container who calls, a load balancer that's waiting for the first container because it doesn't know what's available or not. Or like the Kubernetes has like a 10-second delay depending on how you set your readiness checks. And so when we got to this problem, we were like totally baffled. Like we didn't know how we got here. We were just so confused. Like how did this happen? How did we get here? This was like very late in. This was like 120 services in, and we were like, why is this happening now? Like, why didn't it happen before? Or why have we done differently? Or why have we done wrong? So we trying to break down the problem. So we had hundreds or thousands. Like it is very large now. APIs, all doing something different. All have nothing, but some have some dependencies on others. Many are just isolatable. Like calculate this for me and give it back to me. This wasn't really the problem that lots of people were describing as microservices dependency hell. Those are more about dependencies on libraries, which we never had that problem, so it didn't really apply to this. So we still kept looking, and then this is the conclusion we came to, which was like felt really profound for us. So I'm hoping someone gets something out of this one, which is that this isn't a real world problem. Like the services we've defined are just abstractions that we've created around APIs that help us develop or think about or rationalize the work being done. So if you think about, we have 5 APIs, right? So we have a create client API that's create user. User is an abstraction for us on clients. We have like multiple types of user because everything logs in the same way. So we have create client, which calls create user, which calls create user group, which is really interesting. And then we have a login endpoint, which calls get user, and like super simple stuff. And this would all work fine, right? Except if we assign services. So we create a service that's assigned. It's responsible for users, right? You can get, create, update users with the purple service or service 2, right? There's a yellow service that's responsible for clients, so it's service 1, and there's a green service that's responsible for authentication and authorization. Right? So logging and creating and managing user groups are the green ones. And then now you can see that here there's like suddenly there's a deadlock. If these two containers are talking to each other, like one of them will time out. Oh, all the APIs are timed, so an API can't take longer than it's supposed to take. But like we just started seeing lots of timeouts, not lots, but like 1 in every billion would start timing out. And this is like just very weird for us. And so the conclusion we came to was that services are simply logical groupings of APIs. The only reason we put this stuff together as purple, yellow, and green was when this guy was developing this service, we thought, oh, this feature should be added to this service, which is actually how we broke this up. Like these two are now separate services, and everything's fine. Like, there's no chance of any deadlock, like, ever. These two obviously still look like they belong together, but if we stop seeing the reason for them to belong together or find problems with it, they'll be broken up too. Like they are just logical groupings. There is nothing inherently real world about these things being attached to each other. And these are the reasons why we do it. And then eventually we got to this concept of subservices, which we haven't really named yet. So someone's thrown out the name servlet, which I think is what we use. But it's like, how can we break up the service even further? And to me, this is where like, what are they called? Someone asked about at work the other day. Like serverless function definitions are coming, which is like every API is now its own service, right? Which is just this, but like each one is a different content. Right? It's like there's nothing different from what we're doing except we've just separated it maximum, and it's worked really well for us. So now we never have this problem anymore because we built like tooling so that in our logs we can see the traces between services and make sure there's no deadlocks. Cool. That was exciting.
We are running out of time, so just to go over these very briefly. Other interesting things that came up while we were designing our microservice architecture was authentication and authorization. Krish touched upon this briefly. So we have different types of users. We have clients, services, ghosts, and other types of users, and they all log in to our architecture in the same way. We also have API gateways for all of our front ends, splitting up the data source by the service. So Javier mentioned this, and keeping all the services up to date. very briefly, so for example, if we bump our Carbon Core library, or we want to introduce a new feature that that has a global footprint on all of our services, then we have a tool which enables us to do that, which we call the repo updater, which just loops through all of our services, well, all of our repos, but services are a subset. Similarly, we have a resource updater, which will loop through all of our services and update the CPU allocations and memory allocations, as an example of many other things. Logging and monitoring, this is quite an extensive topic. Touched upon briefly again. So Chris talked about traces, which let us trace a call from the end user all the way through the pipeline and back out again. Error propagation. So for example, if there's a service A here and service B here, and service B communicates with service A, and service B is a client of service A throws an exception, we have error propagation, which means that based on some parameters like the status code or the exception name, the error will propagate here, just as if there was a function call in service B for the same business orchestration. And backwards and forwards compatibility. Present and future work. This is super interesting. So we have if we're designing a new service based on our API design, we have like thin layers of our API and clients which look the same in every service. So we're currently working on auto generation of these, reducing the manual work required to write a service. We're also working on cluster creation. So for example, we're currently running everything in Kubernetes, and if we want to make an update to something in Kubernetes, then we won't update that cluster. This is future work, present and future work, but we'll rather spin up a new cluster with the updated version and then migrate all of our services one by one. Declarative deployments, so abstracting Kubernetes and everything else away from a service. Currently these configurations live in our service, but the goal is in the future to move them out, and therefore making the service wholly just responsible for business logic. Micro front ends, so we already have microservices for our backends, but we want to apply the same principles of microservices and their architecture to our front ends. API scaling. So Krish mentioned this briefly, I believe. For example, if there's service A and service B, and A is being called like once an hour and B is being called like once every millisecond, then we want them both to scale based on their API calls, and not on, for example, CPU CPU usage. Something else we're working on is currently we have HTTPS communication, we have PubSub communication, and we have message queue communication, but we're moving to an even smoother communication via streams. So this is stuff that we're going to be working on, and it's very exciting for the engineering team at Arkera.
Cool, that's all. Thank you for listening.